All right, so g of x is the inverse of f of x, right? And f of x equals that thing right there. What we're going to do is we're going to find the derivative of the inverse at 276, right? So get that kind of into your mind real quick. So in order to do this problem, this is kind of a difficult problem right now. And the reason why is because what we would have to do is we would have to find out what g of x was. And remember, g of x is going to be equals f inverse of x. So what we're actually doing when we're finding g prime of x is we're finding f inverse of x prime. So if we wanted to do this using the tools that we already know, we would have to find f inverse of x and then take its derivative and then finally plug in 276 into that derivative. So the problem is, though, is that we don't have the algebraic tools to do that. We don't know how to find the inverse of a cubic function with other variables, right? With other x squareds and so on and so forth. So we're going to have to be creative here. And speaking of being creative, let's try it. So we're going to try to, once this loads up here, we're going to start with a simpler function, and we're going to see if we can figure out kind of a pattern that we can use with that simple function. So let's get an example going here. Let's say f of x equals x squared, right? And let's say, well, let's make x bigger than 0 just to start with, right? So, and let's let f inverse of x equal g of x. So g of x and f of x are going to be inverses of each other. So you can, it kind of depends on how comfortable you are with this notation, but I'm just going to say, okay, g of x is going to equal the square root of x, because x squared and square root of x are inverses of each other. If I plug one into the other one, I just get an x, right? Which is the definition of an inverse. So now what I'm going to do is I'm going to find what f prime is. It's an easy one here, 2x. And let's find out what g prime is. That's also an easy one. I'm going to rewrite, a little more complicated, I guess. I'm going to rewrite this as x to the 1/2. So we're going to bring the 1/2 down, x to the negative 1/2. So I'm going to write g prime of x as 1 over 2 root x. So now let's plug in some points here. Let's plug in some points. I'm going to pick some easy points here. I'm going to pick 2 and 2. My input for 2 is going to be 4. If I plug 2 into f, I get 4. If I plug 3 into f, I get 9. If I plug 4 into f, I get 16. So what I'm going to do here is I'm going to plug the input into f to find out what f prime is, and I'm going to plug the output into g to figure out what g prime is. So let's do it real quick. Let's find, we'll call this f prime, and we'll call this g prime, and we'll call it g prime of y, because we're going to find in terms of our original function here. So let's plug in 2 times 2 gives me 4. Same thing here, but it's going to be 1 over 2 root, and then I'm going to plug 4, my output, into there. And that gives me 1 over 2 times 2, which is 1/4. So look at those, right? It's kind of interesting. And that's kind of the key to figuring out what we're originally looking for, right? So if you look back here, we're trying to find g prime, so that's the inverse of 276. So if there was a way that we could just use f prime and somehow come up with g prime, that would be really, really easy for us, right? So it's lagging, but we can wait a second. So if you look here, you can kind of see there's a relationship between the input of f and the output plugged into g. Let's look at another one. We shouldn't need all 3, we should just need 2. So let's find the derivative at 3 of f. 3 times 3 is going to be 9. And let's find the derivative, let's plug the output into g prime. So that's going to be 1 over 2 root 9. So that's going to be 3 times 2. It should be 2 times 3. Let me erase that. Hopefully you caught that. 2 times the input gives me 6. So that's going to be 1/6. So what you need to do, if I want to figure this out right here, if I want to figure out what G prime is, right? What I need to do is I need to figure out what F prime is, work backwards, find, here I have the output, work backwards to the input, take its derivative, and then flip it, right? You have the output, work backwards, you have the output right here, work backwards to the input, take its derivative, and flip it. So for example, let's say I wanted to find what G prime of 16 was. G prime of 16, kind of a tough one. So I could just plug it in, but if I wanted to work with F, let's see if I can do it. So what I need to do, 16 is actually the output of the original function. So I need to work backwards to find out what the input is going to be. So 16, if I work backwards the input, I get 4. So I'm actually going to find F prime of 4 and then flip it to find that G prime of 16. So let's find F prime of 4 real quick. So F prime of 4 is going to be 2 times 4, which is going to be 8. So now if I want to work backwards and find out what G prime of 16 is, I just have to flip that, and I get 1/8. Back to the original problem. So again, what I need to do, I have the input right here. I need to take I have the output right here. 276 is the input of G, but it's the output of F. So work backwards and find what F of, we're trying to find F prime of, think about what 276 goes to. Well, 276, if you look at the chart here, if I plug in 5, let me erase some of this stuff. So if I have my domain of X, or of F, and I have my range of F, we'll call it F of X, 276 gets mapped back to 5. So what I can do is I can find the derivative of 5 and then flip it, and that will be equal to this right here. You can find the derivative of 5 and then flip it. So let's find F prime of X real quick. That's going to be equal to 3 x squared plus 12x, right? And now let's find what F prime of 5 was. So that's going to be 3 times 5 squared plus 12 times 5. So that's going to be 75 plus 60. If you're smart, you can just leave it like that, but that's 135. So F prime of 5 equals 135. So that's all I need right there. I found F prime of 5. So now the input is 5. The output was 276. So if I want to find G prime of 276, that is the same as 1 over 135. So the key is to find what they're actually giving you here is the output of your original function. You need to find the input, right? So that's what we did. Once we found this 5 here, that was kind of the key to this problem. We found the derivative of the original equation. We plugged in 5, and then we flipped it, found its inverse. All right, there you go. Peace.